Hello. Okay, so let me show you the first question. This is from last week. So for those who were here last week, we didn't have time to do it. So this is the first question. It's a vectors question from a year 13 paper, but it doesn't have any year 13 vectors. Yeah, so the difference between year 12 and year 13 vectors is year 13 vectors, you include 3D vectors, and this is 2D vectors. So please have a look, read it. I would recommend you to do the sketch. Yeah, the sketch is mainly in geometric problems are going to help you. Let me start doing it. Yeah. Sam, hello. Okay. So please see if you understand. We have a sketch of a triangle OAB. Point C is such as O, C is to OA. So I would try to represent that point C is, if OC is to OA, I'm just going to extend OA to be double. So it will be somewhere here. So this is going to be C. Then point M is the midpoint of AB. So it's going to be somewhere here in the middle. And the straight line through C and M cuts OB at point A. So I'm going to make a line. It doesn't need to be perfect. So line passing this, and this is going to be M. Yeah. So roughly, these drawings never are going to be accurate. So don't trust them. Yeah. Given that OA is A and OB is B, so this vector here is A, and this vector here is B. So all this vector and this vector are A and B. And we have to find CM of A and B. People, sorry, we are just starting with the first question. Whenever they ask you to, these type of questions are very common. So whenever you have to write a vector in terms of other vectors, the only thing that you have to do is look at the vector that we need. So CM is this vector here. So the only thing that we have to do is to try to go from C to M in a way that we know the vectors that we find in the way. Yeah. So we could do something like this, or something like this, or something like this. It doesn't matter, because at the end, when you put them together, you're going to get the same answer. So I think I'm going to do that CM CA, sorry, CA plus AM. Yeah, that's what I'm going to do. CA plus AM. CA, because this is the midpoint, yeah, this vector here is again A, but because it goes that way, it's going to be minus A. Yeah, so this bit here is minus A, sorry. So I'm going to write what I'm saying. CM, I'm going to write a CM is CA plus AM. CA is minus A, because the opposite direction is minus. Yeah, the vectors is just, the minus is just the direction, so minus A. And now, what is this vector? Who can tell me? Or how can I find it? Maybe not straight away, but how can I find vector AM? Anyone? Ryan, tell me.
Would it be half of A to B?
Exactly. And how can I find AB?
It'd be minus A plus B.
Exactly. So AB, vector AB is minus B plus A. So minus B plus A, or A minus B, if you want to write in that order. Yeah. So AB is going to be minus A plus B. Again, I'm trying to go in a different way. And AM is half of AB. Yeah. So I can write that AM is half of A minus B. Yeah. So this is what I'm going to write here. AM is 1/2, and then I'm just going to expand that bracket and write things a bit better. Yeah. So I have 1/2 minus 1 is going to be minus 1/2 A, and then I have minus 1/2 B. Is that correct? Minus 1/2 A minus 1/2 B. I don't think that's correct. Minus 1/2 minus, it should be minus 3/2 plus 1/2 B. So we have done something wrong. So CM is going to be CA, which is minus A, plus AM, and AM is half of AB. And we say AB is B minus A. No, it's minus A plus B. Yeah, this is the other way around, sorry. The negative one is the A. Be careful with the direction. So this is minus A plus B. Yeah, minus A plus B. And when we put them together, sorry. Minus A plus B or B minus A. When we put them together, then we have what we need. Yeah. So this is going to be minus A minus 1/2 is minus 3/2 A and plus 1/2 B. Sorry, because I did it in the other direction. Yeah. We have written CM in terms of A and B. And just the trick with this is try to, if you do the sketch, you see the vector and then you try to go in a way that you know the vectors on your game. Yeah. Now we have to show that ON. So now we are talking about this vector. ON is this scalar times A plus another scalar times B. How do you think we can write that? So I'm talking about ON now. So it's this vector here. And again, I can go in different ways, but we just did this vector. So it's very likely that we are going to use it. Yeah, I would try to use it because that work is for something. What can I do to go from A to N? What can I write? Who can tell me? What do you think? O to N, I can try to go this way. Yes, I know what OC is. So I can say that ON is OC plus CN. Yeah. ON is 2A. We know that. They tell us at the beginning, 2A. And now, how can I write CN? And this is where you have to understand, well, when vectors are parallel, it's just multiple. So they are multiples of each other. So how can I write CN? And where is this lambda coming from? Fraser, what do you think? I cannot hear you. You're mute, but I cannot hear you.
What about now?
No, yes. Tell me.
The BCM plus MN, and you would know that because it's on the same line, MN would be a scalar multiple of CM. Does that make sense?
Even easier. So you're doing the right thing, but you don't need to split it in two. So N is going to be a scalar multiplied by CM. Does it make sense? So CM, sorry, more people are joining. Because Cn and Cm are parallel, I can write one as the multiplication of the other, as a scalar of the other. So Cn is going to be lambda Cm. And I have that, lambda Cm. And I know Cm from the previous part of the question. So I have 2a plus lambda minus 3/2 a plus 1/2 b. Everyone understand what I've done? So any vector, if I have this vector here, which is a, and this vector here, this will be lambda a. So it could be 2a, 3a, 1/2 a, I don't know, but it could be just lambda a, yeah? Two vectors, when they are parallel, they are multiple. And if I rearrange this expression, I'm going to get this one, right? I'm not going to do it because we are dedicating already too much time to this question. Now, hence, prove that ON to NB is 2 to 1. This is quite a common thing in these type of questions, vectors questions, when they ask you about a ratio. So we are talking about this line, and then say that this distance is 2 times this distance. Yeah, that's what they are saying. How can I get a connection between ON and NB, or between ON and OB? Any idea of how can I get that connection? And again, try to use the expression that we found, because these questions are not random. Find this expression, find that expression. Usually you are going to use them, right? This expression here, I'm going to use this expression here, not the one that I wrote. This expression here is ON, is this vector here. This vector is completely parallel to B, which means has no A component. Right? If it's completely parallel to B, the only component that is going to have is this one. So this component is going to be 0. And that's how these questions work, yeah? So because ON is parallel to A, that means that 2 minus 3 halves of lambda is going to be 0. The A component is going to be 0. Yeah? And that means that lambda, sorry, more people, lambda is going to be 4/3, right? 4/3. And if lambda is 4/3, then I can write ON. So ON, look, ON, vector ON is going to be 1/2 multiplied by lambda, which is 4/3 B. Yeah, so this one is 0. I'm keeping this one only. So this is 2/3 of B. B was this vector, the whole thing, yeah, from O to B. If this is 2/3, this is 1/3. So the ratio is 2 to 1. Yeah, and that's the way of finding a ratio in a vectors question. So if you ever have to find a ratio, what you have to do is to try to write this vector in terms of the long one, if you have the information of the long one. Yeah, does it make sense? So this vector is 2/3 of this vector, which means this is 2/3 and 1/3. So this is 2 to 1. Yeah. Any question? These questions are a bit complicated at the beginning, so they require a bit of practice. Like the ones that you have, for example, a parallelogram all made with vectors, and then they ask you to prove that the diagonals intersect in the center and all those. So they are quite typical, but they need a bit of practice. And it's all about understanding how we represent a vector parallel to other, yeah, and using the scalars. Any question? No? Move on into the next one. Okay, more. This one, I know some of you, because radians is from year 13, some of you might not have seen it yet, but it's not difficult. So I'm going to show you what you need for this question. So radians is just another unit for angles. Since that we use degrees, we can use radians. And we have a sector of a circle with center A, radius 7. So this is 7, this is 7, yeah, and we are doing as arc of an arc. Given that the size of this angle is 0.8 radians, find the length of the arc BC. So they are asking us about this length. Remember, when we have degrees, we have a formula for this length. When we have radians, that formula is even easier. So this length, the length of an arc, is just when the angle is in radians, r times the angle. Just that. Super simple. It's not in the formula booklet, you need to remember. Yeah. So the length, I'm just going to write it here. The length is going to be the radius, which is 7 times 0.8. And because we have meters, this is going to be, no, sorry, meters, no, centimeters. Yeah. Just that, r times theta. Then they ask me the area of the sector. So the area, not the shaded area, but the area of the sector, all of these. And again, it's a formula, very simple, that you need to remember because it's not in the formula booklets. So the area of a sector when the angle is in radians is just 1/2 r squared theta. Again, very simple. So the area of the sector is going to be 1/2 times 7 squared times 0.8. Yeah. So it's just using the formula, these questions. And I get 98/5 or 19.6. You can leave either way. 19.6, and because it's area, centimeters squared. When you have units, I always recommend you write the units because sometimes you don't miss marks, but sometimes you do. Yeah? Two formulae, nothing else. Now, the point D is the midpoint of AC. So this point here is the midpoint, and we know this is 7. So we know this distance is 3.5. Yeah. The region R showed in the some shaded in the figure 1 is bound by CD. So all these 3 lines. Yeah, the arc, this line, and this line. We need to find the perimeter to 3 significant figures, and then we will need to find the area to 3 significant figures. The perimeter. Can you all try to work that perimeter, please? So there we have some information, but we don't have all of it. Yeah. So that perimeter. We have this length. We found that is 5.6. We have this, which is half of the radius. So this is 3.5. So I'm going to write here, this is 5.6. How can I find the missing line? So how can I find this one? Can you type in the chat, please? So please find the chat. It's just like a symbol like this. Yeah, like a message thing. And tell me, what do you think I can use? So don't give me the number, don't make the calculation in the chat. What can I use? Excellent. Cosine rule. Perfect. So cosine rule, remember, it connects 3 sides and 1 angle. So in this case, I have one side, one angle, and I need another side. So I'm going to use the cosine rule. And I can use the cosine rule if I have radians. Just the calculator has to be in radians. Yeah. So let's going to at least write the formula. And if you haven't seen radians, don't worry. I can use the calculator if you don't know how to do it today. So cosine rule, I'm going to start with the opposite of the angle square. So don't worry too much about the numbers or the letters. Is just all the one that goes squared alone is the opposite to the angle. So this one, in this case, is the one that I'm looking for. I'm going to call it x. Yeah. So I'm going to write x squared is equal to the other 2 sides squared minus 2 times the product of the sides and cos of the angle, which is 0.8. Yeah. If you know how to change your calculator to radians, when you do this cos, your calculator must be in radians. Yeah. If you don't know today, you can investigate, or when you learn radians at the school, you will learn how to do it. But this is just changing the units of the radius and the way we find x. Yeah. Can you please do it with me? And then we check that we get the same. I get 51 point something, and then you do the square root, 7.176. You get that value? Oh, they don't tell us. BD is 5.21. 5.21. So 5.21. This is 5.21. 3 significant figures, centimeters. 3 significant figures. Yeah? Is it clear? So cosine rule, don't disconnect these questions. The cosine rule and sine rule, you will use them in many geometric problems. It doesn't need to be exactly just a triangle. Yeah, it could be part of this question. Now, we have to find, sorry, that's x, that's not the whole thing. So the perimeter is going to be that 5.21 plus the 5.6 that we found. That was 5.6? Yeah. Plus the 3.5, yeah? So this one, plus 3.5. And your final answer, again, I'm going to check here, and I give you the answer. So perimeter is 14.3 centimeters to 3 significant figures. Yeah? That's the perimeter. How am I going to find the area? I'm going to find, I have the area of the sector. Remember, we found it here. And I'm going to subtract this triangle. How I'm going to find this triangle area? Who can tell me? So I have the area of the whole sector. If I subtract this triangle, I will have the shaded area. How am I going to find the area of this triangle with the information that I have? Do you want to type in the chat, or someone wants to tell me? Remember, I have when I don't have a right angle triangle and I don't know base and height, I have a formula, which is not in the formula booklet. Exactly. It's going to be 1/2. You are writing it in the chat. So the area of the triangle is going to be 1/2, and we always do 2 sides and sine of the angle in between. So in this case, this is going to be 1/2, 7 times 3.5 sine of this angle. Yeah, that's what I'm doing. 7, so one of the sides, multiplied by the other side, multiplied by the sine of the angle that is in between. That is the 0.8 in this case. Yeah, 0.8. Calculator in radians. You get the area of the triangle. Do we have it? Is 8.78. So that means the shaded area is the area of the sector, so 19.6 minus 8.78. Yeah, and again, I'm going to give you the answer here. So 10.8. 10.8 centimeters squared. Does it make sense? So these questions about gradients, you are going to use always the length of the arcs, the area of the sector, and then a connection with sine rule, cosine rule, area of triangles, and things like that. Sometimes Pythagoras if you have a right angle triangle. And so, yeah. Any question? No? Okay, more. This one here. So we have, and again, this is something that you could do at the end of year 12 because it's a polynomial, but it's in a year 13 paper. So all of them in year 13 papers. So we have a sketch of part of this curve, which is a cubic. Yeah, so we have this function here. The curve has a maximum turning point at A. This is A. Using calculus, show that the x-coordinate of A is 2. How am I going to find the coordinate of the turning point? Differentiating and make it equal to 0. Yeah, so can we quickly differentiate that function, please? And make that equal to 0. So dy by dx. And I would recommend you, if you want to get all the marks for working out and everything, don't just write the derivative and make it equal to 0. Write at least this. So they know you are doing the derivative, but you have to show that you are doing the derivative. Because if you make a mistake, then nobody has clear what you are doing. How do you know? You have to differentiate because you have to find the turning points. To find the turning points, you always make the derivative equal to 0. The derivative is giving you the gradient of the tangent, and in the turning points, the tangent is horizontal. Yeah. So we differentiate is going to be 8 plus 2x minus 3x squared. This is going to be equal to 0. And is a quadratic. I'm going to just rearrange it. When we solve it, we are going to get one negative value and one positive value. And the one that we are looking for is the positive one. So I get 2 and minus 4/3. So 2 and minus 4/3. So I would write something like this. So factorize. So they see some, sorry, 3x plus 4 equal to 0. So x is 2, x is minus 4/3. Yeah. So you use the calculator, but then write the factors. And the one that we are looking for is this one. Yeah. Or you could even substitute the x equals 2 in this expression and see that that is equal to 0. You could perfectly do that. Yeah. So if they give you already the value, instead of finding it, you can just substitute and see that it's 0. Region R, shaded here, is limited by the x-axis, the y-axis, the line from O to A, where O is the origin, and we have to find using calculus the exact area of R. So we have to find the area of R. For these questions, where you have to find the area trapped between two lines, we have two options. So all of you are thinking, okay, I'm going to integrate between 0 and 2. Yeah, this is an integration question. I'm going to integrate between 0 and 2. I could, so if this is, let's call it y1. So this function is y1. And I had the line, so imagine I have the line. I could find it. I don't have it, but I could find it. I could do the line that is above minus the line that is below the x. Yeah, and integrate the difference between the two lines. And sometimes it's more convenient. Or I could integrate the function that I have without finding the line and then subtract the triangle. What you really need to remember is every time you integrate a function, what you are finding is all the area below, yeah, up to the x-axis. So in this case, if I integrate this polynomial between 0 and 2, I'm finding all this area. which means the pink, the shaded area is all the pink minus this triangle. So in this question, it's just faster to remove the triangle. Yeah, can we do that, please? So we integrate to find the pink area, and when we find the area of the triangle. To find the area of the triangle, I have the base and I need the height. Yeah, I have the base, need the height to find the y. But I have how? Yeah, so if I substitute the x by 2 here, I will find the y. Yeah, so let's going to do that. First, I'm going to find the pink area integrating the function. I'm going to do it in another page. So please, let's going to integrate between 0 and 2. The area, I'm going to write p from the pink is 10 minus 8x, no, plus 8x, plus 8x squared minus x cubed. Dx. We integrate. Remember, you can do this with a calculator. If you do that with a calculator and you give your value, you are going to lose the marks. Yeah. So you really want to write what is the integral of that function. So 10x. Remember, we increase the power by 1 and divide by the new exponent. So 8x squared divided by 2 is 4x squared. Then x cubed divided by a new exponent, and x to the power of 4 divided by a new exponent. And then you want to write the 0 and the 2. Substitute the 2, so you have 10 times 2 plus 4 times 2 squared plus 2 cubed divided by 3 minus 2 to the power of 4 divided by 4. And then everything else is 0. And now you write your number. Yeah. And in this, when you write the number, you can substitute this in the calculator or use this in the calculator. Yeah, it really doesn't matter. I would even substitute this in the calculator so we don't make mistakes. Do you have a value there? Anyone has a value? So between 0 and 2, I get 104 divided by 3. Yeah, area of the triangle. For the area of the triangle, we are going to do 1/2 base times height. Base is 2. We need the y coordinate of A. The y coordinate of A is when we substitute here the x by 2. It's just that, yeah, because that point is in my function. So when x is 2, I have 22. So when x is 2 here, when x is 2, y is 22. Yeah, so this point is 22, if I've done correctly. So the area of the triangle is 1/2 base times height, which is 22. So the shaded area is going to be the pink area minus the triangle. Yeah, which is 38/3. Does it make sense? Everyone, show me thumbs if you have the button for the thumbs, or ask me questions if you need to. 38/3. Yeah. Be sure when you do integral questions that you don't go into the calculator and substitute the value, because your calculator can integrate, yeah, the definite integrals, but you really want to do these 2 steps to get the max. Yeah. More questions? We have a moments question that some of you maybe haven't seen it. It's one of the first chapters in mechanics in year 13. So remember, in year 12, all the mechanics is with particles. In year 13, we introduce rigid bodies. So we are going to have bars, planks, rods, ladders, things like that. And apart from having forces, we are going to have moments. The moments are just telling us how the thing is trying to rotate or to spin. Yeah, when we have a particle, the particle will spin. When we have a rod, if we apply a force, we will have a rotational effect. Yeah, and that's what the moments are counting. So again, I would recommend you to do the sketch and write or draw the forces while we read the question. Yeah, so please do the sketch. You have a bench. It's a plank resting in a horizontal position on two thin vertical legs. So this one and this one. The plank is modeled as an uniform rod. I'm going to remind you, uniform rod, that means that the weight is in the midpoint. Yeah. We know the length is 2.4 meters. The mass is 20 kilograms. Because they give me the mass, what I'm going to write for the weight, can you type in the chat? So if the mass is 20 kilograms, what is the weight? Because remember, I'm representing the forces. Exactly. So I'm going to draw in the midpoint 20 G. If they give me the newtons, please don't write the G. Yeah. So the G is just to make it from the mass to the weight. Now, we know these distances, so 0.4, 0.4, and it says two pupils, Arthur and Beatrice, sit on the plank. Arthur has mass 60 kilograms and sits at the middle of the plank. So he's sitting here. Yeah, we say this is the midpoint, so this boy is sitting here as well. It's 60 kilograms, so I will have another force in the same place, which is 60G. And then Beatrice is 40 kilograms and sits at the end P. So I have Beatrice sitting here and it's 40G down. What other forces I have in my plank? Because it's on two supports, I will have the reaction force on those supports. I have a force here. Fraser, tell me.
I was going to say the normal reaction forces.
Ah, exactly. That unless they tell me anything different, I'm going to write that they are different. Yeah. So sometimes they say one is double than the other or triple than the other. So then you can write R and 2R, but in this case, I'm just going to call them different. Yeah. Reaction at the supports. Now, it's in equilibrium, modeling pupils as particles. Find the magnitude of the normal reaction between the plank and the leg at Q and the magnitude of the normal reaction between the plank and the leg at R. So they're asking me about this force here and this force here. Yeah? Moments questions. They are all going to be in equilibrium. All of them. Which means the resultant force is going to be 0 and the moment about any point is going to be 0, the resultant moment. Yeah, we can apply one or both. This one is easier to apply, but because this is a moment question, we will have to take moments. So we are not going to get away just using forces. But every time that you can use forces, try to use forces because it's simpler. So I'm going to find RQ or RR first, taking moments, and then I'm going to use the other one to find the missing force. Which point I can take moments about? I can take moments about any point. If you think a minute, which is the most convenient point, your question could be just a single line, and you can do the question in 30 seconds. Can you tell me what is the most convenient point to find RR? So if I want to find this one, what is the best point to take moments about? Who can tell me? So if I try to find this one, what is the best point to take moments about? Anyone? Q. Perfect. Ryan, why Q?
Because then you can get rid of RQ.
Exactly. If I take moments about Q, this won't be my equation. I have only one unknown and I can find it straight away. If you take moments about other point, then you will have two unknowns, which is okay because we can solve simultaneous equations, but the simpler you get the equations, the better. Yeah. Moments about Q. First thing you have to think is in which direction the moments are. Yeah. So this, around this point, if I apply a force down, my plank is going to rotate anti-clockwise. So this force is going to produce an anti-clockwise moment. These two, when they spin about this point, are going to produce a clockwise moment. Yeah? If we push down and we hold here, it's going to be clockwise. You have to imagine that you are holding the bar here, like with a pin. Yeah? And this one, about this point, if you push up, is going to spin anti-clockwise. So what we are going to do is that the anti-clockwise moment is equal to the clockwise moment because it's balanced. So we are going to write that. Clockwise moment, And you are going to write which point you are taking moments about. So it's important because if not, for the examiner, when you mark a paper, it's almost impossible to know. If you make a mistake, it's impossible to know what you're doing. So you write which point you are taking moments about. And we are going to say that the clockwise moment is going to be equal to the anti-clockwise moment. Clockwise moment is the one that these two forces produce together. And because they are applying the same point, I can put them together. So I can say that that's ATG, yeah? So it's like one bigger force. ATG multiplied by this distance. So the moment is the force multiplied by the distance. The force is ATG multiplied by this distance. This is the midpoint. This is 1.2, and this is 0.4. So this is going to be 0.8, yeah? 0.8. Multiplied by 0.8 is going to be equal to the anti-clockwise moment, which is this one and this one. Force multiplied by the distance. So 40g times 0.4, force multiplied by the distance. And the other one, this one again is force, which is the one that I need, RR, multiplied by this distance. And this distance is, the whole thing is 2.4. If this is 0.4, this is 2 minus 0.4. Is 2 minus 0.4? Yeah, it's 1.6, no? This distance is 1.6. 1.6? Yeah, 1.6. So RR times 1.6. Yeah, and from here, we are going to find RR. Is confusing for those who haven't seen moments? Probably, no? And I get that RR is 294 newtons. Did you get that, Ali? 294? Is, yeah, you get the same. We can leave it in terms of G or leave it like this. And now, so this is RR. They are asking us the other one. You could, again, take moments. And now, because you know this one, you can take moments about any other point. But it's easier if we use the resultant's force equal to 0, which means that the forces pointing up are going to be equal to the forces pointing down. Yeah, so forces pointing up equal to forces pointing down means that RQ plus the one that I just found, so the two forces pointing up, I'm resolving forces. So RQ plus the one that I just found is going to be equal to all the forces pointing down. Yeah, so this one and these two combined together. So RQ is going to be that. Yeah, so and I get 882 newtons. Yeah, 82 newtons or 90G if you prefer. And this one is 294, 30G. Yeah. Very simple if you take a minute to think which is the most convenient point. Now, Beatrice stays sitting at P, but Arthur now moves and sits on the plank at the point X. Given that the plank remains horizontal and in equilibrium and that the magnitude of the normal reaction between the plank and the leg at Q is twice the magnitude of the normal reaction at R, we have to find the distance QX. So now, every time you change something around in a plank, yeah, you remove a force, you put a new force, or you move the point of application, these forces are going to change. Yeah, so we cannot assume that the value that we just found is going to be correct. So we are just going to think about them again like new forces. They are telling me that the boy that was the 60 kilograms is sitting now somewhere else. So I'm going to write that the boy is sitting here, for example, yeah, at point X. He was 60 kilograms, and they tell me that the reaction at Q is twice the reaction at R. So this one is twice this one. So I'm going to call one R and the other two R. Yeah. And they ask me the distance QX. So they are asking me QX, this distance. Be careful because it's not from P, it's this distance here. QX. QX. Right? I can very easily find these forces here, applying sum of forces. Remember I told you, every time you can use the sum of forces is the easiest. So, and because it's the same unknown, really, if I find R, I have both of them, I can do sum of forces. So I'm going to do that. I'm going to find R, and then I'm going to take moments to find this one. Let's go to do that. So sum of forces equal to 0. Resultant force is 0, means forces pointing up, 2R plus R. So 2R plus R pointing up is going to be equal to 40G plus 20G plus 60G. Yeah? So 40G plus 20G plus 60G, which means 3R is what? 120G. So R is 40G. That's going to help us because this is 40G and this is 80G. So we know all the forces. Now we need this distance here, and we are going to take moments. We can take moments about any point again. When you are trying to find a distance, my recommendation is to use one of the sides of the distance, or this point or this point. It's a bit up to you. If this coincides with one of the sides of the plank, that would be better, but it's not the case. So I'm going to choose D, for example. So I would like you to think, first of all, in which direction the moments go about Q again. I know we did it before. This one is going to be anti-clock. This one is going to be clock. This one is not producing any moment because it's passing the point, so the distance is 0. And this one, anti-clock. And I hope you have seen this chapter because this is not, it's very confusing. Right? So clockwise moment equal to the anti-clockwise moment. We write an equation and we will find X from there. So again, I'm going to write that I'm taking moments about Q. So taking moments about Q, that must be 0. So the clockwise moment is going to be equal to the anti-clockwise moment. So clockwise, I have 60G times this distance, which is X. So 60G times X. Plus, this one is 20G times this distance that we said before it was what? 0.8? That one was 0.8. 20G times 0.8 was 0.8, no? And then, so we have done these two, and now this one is going to be 40G times 0.4. So 40G times 0.4. And the other one, this one is 40G multiplied by this distance again. That is what? So this whole distance, this is 1.6, no? 1.6. 40G times 0.6. 40G times 1.6. Yeah. And from here, we find X. Yeah. We can cancel all the G's. It's going to be easier. And then I'm going to tell you what we get. So we get 1.07 meters. 1.07 meters. Just solving that equation. So all these questions are about, because they're in equilibrium, always are going to be in equilibrium, resolving forces and moment about one point. If we think a bit in which point, the questions look, they are super, super quick. Yeah. Any question? Was it very confusing for those who didn't the moment? Yeah. Okay. Let's going to do one more, or maybe we have a couple. So this one, we have Siad, I'm not sure how you say the name, is training to become a long distance swimmer, and he trains every day by swimming lengths at his local pool. The length of the pool is 25 meters, and each day he increases the number of lengths that he swims by 4. So every day he swims 4 more lengths. Yeah. On the first day of training, he swims 10 lengths of the pool. So the first day, I hope you are already seeing that this is a type of sequence, a kind of a sequence. So on the first day, I'm going to call it U1. He swims 10 lengths. On the second day, because he do 4 more, we are adding 4 every time. He swims 14 and so on. Yeah. So we have an arithmetic sequence. First term is 10 and the common difference is 4. Yeah. Again, some of you might have not seen sequences and series, but it's one of the first chapters in Year 13. Now, write down an expression for the number of lengths Siad will swim on his nth day of training. This is the nth term. Yeah. Remember, the nth term of an arithmetic sequence is not in the formula booklet. If you are not able to remember, it's very easy to deduce. Yeah. So remember, the first term is A. Second term will be A plus the common difference. Third term, it will be A plus D. And the nth term, it will be A plus n minus 1. Yeah, because this number is always 1 less than here. Yeah. So this is the common, the general term, the nth term. So in case of this question, un is 10 plus n minus 1 multiplied by d, which is 4. Yeah. If you want, you can expand the bracket and you can write that this is 10 minus 4, 6. So 6 plus 4n, or 4n plus 6. Doesn't matter. Yeah, you could even leave it like this. It's okay. That's the nth term. That's what they are asking me. Now, Siad target to be able to swim at least 3,000 meters in 1 day. Determine the minimum number of days he will need to train to reach this target. How am I going to do that? Content me, Fraser.
Would you work out how many lengths he needs to do first,
Mhm.
and then you'd set the equation equal, like the un would equal 6 plus 4n, and you'll be able to find out what the nth day is?
Exactly. That's what I'm going to do. So 3,000 meters, be careful because it's not 3,000 lengths. So you could be there forever. So 3,000 meters, because the pool is 25 meters. If we divide 3,000 by 25 is 120 lengths. So what we are going to do is, and you did this type of questions a long time ago when you did this in year 8, year 9. So we are going to make the nth term equal to 120 and find n. It's very likely that in these questions, you don't get a whole number. Yeah. So then we think what we do. So n is going to be 114 divided by 4 is 28.5. How many lengths he need? The minimum number of days. So there, n is the number of days. Yeah. So if he does, well, in this case, we will round up anyway. So he will need 29 days. But please be careful when you have modeling questions and you have to round numbers. Always consider if you're rounding up or down. So don't just round to the closest number. You would round to the closest number when you're just giving answers. But when you are in modeling questions, imagine here I get 28.1. You will round to 28, sorry. Yeah, you will round down because it's closer to 28. But in 28 days, he won't have swum 3,000 meters. He will be very close, but he wouldn't pass the 3,000 meters. So even if it's 28.1, you should round to 29. Just so be very careful with the roundings, because in modeling questions, you have to think a tiny bit, yeah, if that would be enough and all that. So he needs 29 days. Then Seat's coach claims that when he reaches his target, he will have covered a total distance of over 50,000 meters. Determine if Seat's coach is correct. How can I check that? Can you type in the chat, please? You are super quiet. How can I check? What can I do to check if when he reaches his target, so when he has swum 3,000 meters in a day, that means that he has covered more than 50,000 meters. So when he reaches the 3,000 meters per day, all those days of training hasn't been 50,000. What can I do? Tell me in the chat, or just unmute and tell me. What do you think I can do? Ryan, go on, tell me.
Do you have to use that SN formula and then make it like less than or equal to whatever to 50,000?
Or just
Yes,
find
points.
S, yeah, so I don't need to make it equal or smaller. I'm just going to find S29 and see how many meters they are and to see if it's more or less than 50,000. So that's what I'm going to do. I'm going to add all the lengths that he has done over 29 days to see how many meters he has run. Yeah. So remember, we have this formula in the formula booklet. So the general term we don't, the SN we do. So the SN is n halves 2a plus n minus 1d. So this is the formula of n days added together. So in this case, we have 29 over 2. The first day he swam 10 lengths, then plus n minus 1 is 28, and the common difference is 4. So we are going to find, and these are lengths, yeah, the 10, the 14th, 18th, they were lengths. Then we need to multiply by 25 meters because here we are comparing with meters, yeah? So let's going to see how many meters he swam in these 29 days. I get 1,914 lengths, which is 47,000. So I'm multiplying by 25 meters per length, 47,850 meters, which is less than 50,000. So it's very close. So the coach is not correct. Yeah. What do you have to answer to this? The coach is not correct. Please answer what they're asking you. Yeah. The coach is not correct. He swam less than 50,000. Yeah, so please answer what they're asking you. Determine if the coach was correct. It's not correct. He swam a bit less. Yeah? Any question? It's not uncommon that the sequences and series questions are modeling, and sometimes are a bit difficult to read. There you go. Okay, I'm going to do one more, but I would like to do one statistics. So I have one statistics here. Yeah, this one. This is GR12 content, so all of you should have seen this. It's hypothesis testing that I know you don't like it at all. So we have Nasir is playing a game with two friends. The game is designed to be a game of chance. So the probability of Nasir winning each game is 1/3. And Nasir and his friends play the game 15 times. Find the probability that Nasir wins exactly 2 games. If you remember GR12 statistics, this is a probability distribution that you need to know. What probability distribution is this one? Can you tell me in the chat, please? And if you remember the parameters, please write even the brackets, so wherever you want. So what I will write here is a binomial. And if I have to write the parameters, what I will write in my brackets? All of you, please. What I'm going to write for that variable, which is the number of games that Nasir wins. 15 1/3. Come on, Oli Fraser. 15 1/3. Exactly. So this is a binomial. Usually just for writing this at the beginning of the question, you get a mark. Let me show you in this one. Yeah, look. Just for writing that this is a binomial, you get 1 method mark. So it's important that you write that. Then they are asking us the probability that he wins exactly 2 games. So we want to know what is the probability that x is equal to 2. Remember, calculator binomial PD. So when I have equal, is binomial PD, probability distribution. So you just go to your calculator, to your probabilities, distributions, binomial PD, x is 2, n is 15, and p is 1/3. Please don't divide and write the decimals, just type 1/3. That's completely fine. And then we get 0.0599. Yeah? Now, probability that he gains more than 5 games. Most of the calculators don't have the greater, they have the smaller or equal. Even if your calculator has the greater, I would recommend you to learn well how to do the smaller or equal, because you might need it for critical regions. Yeah, so it's important that you understand. Greater than 5 is what? How I'm going to rewrite that with the smaller or equal? I'm going to write 1 minus, yeah, tell me, Fraser, 1 minus?
Is it the probability of x being less than 6?
Less or equal than?
6. Or is it 4? I don't know whether it's 1 above or 1 below.
Okay, let's think. So I need the probability that is greater than 5, which is 6 and above. So I'm going to do 1 minus the rest. So what I'm going to write? You tell me.
The 1 minus the probability of x being less than or equal to 6.
No, because then I would, so if I want greater than 5, that means 6 and more. If I'm doing the 1 minus, I have to do 1 minus the other bit, and the other bit is up to 5.
Oh, so it's the 4.
Is the 5. You say 6, no? You didn't say 6 here? I think you did say 6. If you say 5, sorry. But if I need greater than 5, it means 6 or more. So if I do the 1 minus, is 1 minus the other bit, which is up to 5. Yeah, so this is what I have to find. So calculator, and in this case, I need to do binomial CD, cumulative distribution. So you need to change the function in your calculator. Yeah. Binomial CD, x is 5, n is 15, and p is the same. So 1 minus 0.6184. We do 1 minus that, which is 0.3816. Yeah, so this is this probability, this is this probability. And now, very quickly, we are going to do the hypothesis testing. Most of the probability questions that you're going to find with binomial are going to have a hypothesis test. So Nasir claims that he has a method to help him to win more than 1/3 of the games. To test this claim, the 3 of them played the game 32 times. So now n is 32, not 15. Yeah, be careful because it's common that it changed. And Nasir won 16 of these games. So this is like the observed value in the sample, right? Stating your hypothesis clearly, always, even if they don't tell you, test Nasir claim at 5% significant level. We are going to do this very quickly. Write the hypothesis, do the test, and write a conclusion. That's what Jury has to do in hypothesis testing. For binomial, H0 is always P equal to the probability, always, regardless of what you think, or he thinks, or they are supposed to prove. Then H1 is going to change depending on the question. So we are testing greater, smaller, or different. In this case, he thinks that the probability is more than 1/3. So this is what we are testing, P greater than 1/3, right? And now what we are going to do is to check what is the probability of getting the observed value or more. So if we are testing greater, we are going to check what is the probability of x being greater or equal, always with the equal, the observed value, which is 16. And we have now a binomial 32 1/3. Yeah, 32 because we are doing 32 trials, and 1/3 because we are assuming this one correct until we prove the opposite. Yeah. Now, what is this probability? 1 minus probability of x smaller or equal than what? If I want 16 or more, I'm going to do 1 minus this probability. So 1 minus 1 less. Yeah. Calculator, be careful because now n has changed and we have 1 minus. So again, binomial PD, CD, binomial CD, x is 15 and 32, and the probability is 1/3. This value is 0.9623. That means this is 0.9623. This value is 0.0377, and we are going to compare this with the significant level. The significant level was 5%. This is smaller than the significant level. Yeah, so 0.0377 is smaller than the significant level. Yeah, because it's smaller and the significant level is already very small. It's just 5%, sometimes it's even 1%. Is very unlikely to happen. So is very unlikely to get this value if this is true. So this is very unlikely to be true. So what are we going to do? Reject it and accept the other one. So if this is smaller than the significant level, that means it's very improbable to be true, very unlikely. Yeah. So we are going to reject H0. And every time that we reject H0, we accept H1. That is called alternative hypothesis precisely for that, because it's the one that we are accepting. And now we have to write a conclusion. So this is not your conclusion. I tell you in a minute. So your conclusion should be something like, there is enough evidence to support that now the probability is more than 1/3. So he was saying that he now wins more than 1/3. And there is enough evidence to support that. Yeah, so you can say that there is enough evidence to support that he wins more than 1/3, or his claim is correct, but you have to say a line at the end. There is enough evidence to support his claim or that he wins more than 1/3. Yeah. Any question? Apart from the one that you type in the chat? No? Okay, so I'm going to answer that. If you need to go, please feel free to go. I'm doing this every Saturday at 2 p.m. The first one each month is free. You don't have to rebook it. So if you are joining in a month, you will get the link anyway. If you want the link to join the others, then you have to book on my website. Yeah. See you soon, hopefully. And if you want to say to answer this question, so you ask me why P is equal to 1/3. So we are always writing two hypotheses. H0 is going to be always P equal to the probability that you are testing. Even if you think it's more, it's less, it's different, it doesn't matter. You are going to write always P equal to the probability that you are testing. This one is the one that you have to read carefully the question and decide if you are testing that is greater, smaller, or different. So this one is always with the equal. This one is the one that can change. So you have to go to the question and see if they are talking about more, less, or different. Yeah, does it make sense?